Hi, greetings to all of you. Today we will take a tour of the most popular machine learning algorithms. It is useful to tour the main algorithms in the field to get a feeling of what methods are available. There are so many algorithms that it can feel overwhelming when algorithm names are thrown around and you are expected to just know what they are and where they fit. I want to give you two ways to think about and categorize the algorithms you may come across in the field. The first is a grouping of algorithms by their learning style. The second is a grouping of algorithms by their similarity in form of function. Both approaches are useful, but we will focus in on the grouping of algorithms by similarity and go on a tour of a variety of different algorithm types. You will have a better understanding of the most popular machine learning algorithms for supervised learning and how they are related. Okay, let's get started. Algorithms grouped by learning style. There are different ways an algorithm can model a problem based on its interaction with the experience or environment or whatever we want to call the input data. It is popular in machine learning and artificial intelligence textbooks to first consider the learning styles and an algorithm can adapt. There are only a few main learning styles or learning models that an algorithm can have, and we will go through them here with a few examples of algorithms and problem types that they suit. This taxonomy or way of organizing machine learning algorithms is useful because it forces you to think about the roles of the input data and the model preparation process and select one that is the most appropriate for your problem in order to get the best result. Let's take a look at three different machine learning styles in machine learning algorithms. Supervised learning. The input data is called training data and has a known label or result such as spam or not spam or a stock price at a time. A model is prepared through a training process in which it is required to make predictions and is corrected when those predictions are wrong. The training process continues until the model achieves a desired level of accuracy on the training data. Example problems are classification and regression. Example algorithms include logistic regression and the backpropagation neural network. Unsupervised learning. Input data is not labeled and does not have a known result. A model is prepared by deducing structures present in the input data. This may be extract general rules. It may be through a mathematical process to systematically reduce redundancy, or it may be to organize data by similarity. Example problems are clustering, dimensionality reduction, and association rule learning. Example algorithms include the appropriate algorithm and k-means. Semi-supervised learning. Input data is a mixture of labeled and unlabeled examples. There is a desired prediction problem, but the model must learn the structures to organize the data as well as make predictions. Example problems are classification and regression. Example algorithms are extensions to other flexible methods that make assumptions about how to model the unlabeled data. Overview of machine learning algorithms. When crunching data to model business decisions, you are most typically using supervised and unsupervised learning methods. A hot topic at the moment is semi-supervised learning methods in areas such as image classification, where there are a large data sets with very few labeled examples. Algorithms grouped by similarity. Algorithms are often grouped by similarity in terms of their function. For example, tree-based methods and neural network-inspired methods. I think this is the most useful way to group algorithms, and it's the approach we will use here. This is a useful grouping method, but it is not perfect. There are still algorithms that could just as easily fit into multiple categories like learning vector quantization, that is both a neural network inspired method and an instance based method. There are also categories that have the same name that describe the problem and the class of algorithms such as regression and clustering. We could handle these cases by listing algorithms twice or by selecting the group that subjectively is the best fit. I like this later approach of not duplicating algorithms to keep things simple. We will list many of the popular machine learning algorithms grouped the way we think is the most intuitive. The list is not exhaustive in either the groups or the algorithms, but I think it is representative and will be useful to you to get an idea of the lay of the land. Please note there is a strong bias towards algorithms used for classification and regression, the two most prevalent supervised machine learning problems you will encounter. If you know an algorithm or a group of algorithms not listed, put it in the comments and kindly share it with your friends. Regression algorithms. Regression is concerned with modeling the relationship between variables that is iteratively refined using a measure of error in the predictions made by the model. Regression methods are a workhorse of statistics and have been co-opted into statistical machine learning. This may be confusing because we can use regression to refer the class of problem and the class of algorithm. Really, regression is a process. The most popular regression algorithms are ordinary least squares regression (OLSR), linear regression, logistic regression, stepwise regression, multivariate adaptive regression splines, MARS, locally estimated scattered plot smoothing, LOESS, instance-based algorithms. Instance-based learning model is a decision problem with instances or examples of training data that are deemed important or required to the model. Such methods typically build up a database of examples data and compare new data to the database using a similarity measure in order to find the best match and make a prediction. For this reason, instance-based methods are also called winner-take-all methods and memory-based learning. Focus is put on the representation of the stored instances and the similarity measures used between instances. The most popular instance-based algorithms are k-nearest neighbor (KNN), learning vector quantization (LVQ), self-organizing map (SOM), locally weighted learning (LWL), super vector machines (SVM). Regularization algorithms, an extension made to another method, typically regression methods, that penalizes models based on their complexity, flavoring simple models that are also better at generalizing. I have listed regularization algorithms separately here because they are popular, powerful, and generally simple modifications made to other methods. The most popular regularization algorithms are Ridge regression, least absolute shrinkage and selection operator, lasso, elastic net, least angle regression, LARS. LARS. Decision tree algorithms. Decision tree methods construct a model of decisions based on actual values of attributes in the data. Decisions fork in tree structures until a prediction decision is made for a given record. Decision trees are trained on data for classification and regression problems. Decision trees are often fast and accurate and a big favorite in machine learning. The most popular decision tree algorithms are classification and regression tree, CART, iterative dichotomizer 3, iterative dichotomizer 3, ID3, and C4.5 and C5.0, different versions of a powerful approach. Then chi-squared automatic interaction deduction, CHAID, then decision stump M5, conditional decision trees. Next, we will have a look on Bayesian algorithms. Bayesian methods are those that explicitly apply Bayes' theorem for problems such as classification and regression. The most popular Bayesian algorithms are naive Bayes, Gaussian naive Bayes, multinomial naive Bayes, averaged one dependence estimators, AODE, then Bayesian Belief Network BBN, then Bayesian Network BN. Clustering algorithms. Clustering, like regression, describes the class of problem and the class of methods. Clustering methods are typically organized by the modeling approaches such as centroid-based and hierarchical. All methods are concerned with using the inherent structures in the data to best organize the data into groups of maximum commonality. The most popular clustering algorithms are k-means, k-medians, expectation maximization, EM, and hierarchical clustering. Association rule learning algorithms. Association rule learning methods extract rules that best explain observed relationship between variables in data. These rules can discover important and commercially useful associations in large multidimensional data sets that can be exploited by an organization. The most popular association rule algorithms are a priori algorithm and ECLAT algorithm. Artificial neural network algorithms. Artificial neural networks are models that are inspired by the structure and or function of biological neural networks. They are a class of pattern matching that are commonly used for regression and classification problems, but are really an enormous subfield comprised of hundreds of algorithms and variations for all manner of problem types. Note that I have separated out deep learning from neural networks because of the massive growth and popularity in field. Here we are concerned with the more classical methods. The most popular artificial neural network algorithms are perceptron, multi-layer perceptron, backpropagation, stochastic gradient descent, Hopfield network, and radial basis function network. Deep learning algorithms. Deep learning methods are a modern update to artificial neural networks that exploit abundant, cheap computation. They are concerned with building much larger and more complex neural networks, and as commented above, many of the methods are concerned with very large data sets of labeled analog data such as image, text, audio, and video. The most popular deep learning algorithms are convolutional neural networks CNN, recurrent neural networks RNN, long short-term memory neural networks LSTMs, and stacked autoencoders, deep Boltzmann machine DBM, and deep belief networks. Then DBN, the dimensionality reduction algorithms. Like clustering methods, dimensionality reduction seek and exploit the inherent structure in the data, but in this case in an unsupervised manner or order to summarize or describe data using less information. This can be useful to visualize dimensional data or to simplify data, which can then be used in a supervised learning method. Many of these methods can be adapted for use in classification and regression. Principal component analysis PCA, principal component regression PCR, partial least squares regression PLSR, summon mapping, multidimensional scaling MDS, projection pursuit, then linear discriminant analysis LDA, mixture discriminant analysis MDA, quadratic discriminant analysis QDA, then flexible discriminant analysis FDA. Ensemble algorithms. Ensemble methods are models composed of multiple weaker models that are independently trained and whose predictions are combined in some way to make the overall prediction. Much effort is put into what types of weak learners to combine and the ways in which to combine them. This is a very powerful class of techniques and as such is very popular. They are bootstrapped aggregation, bagging, adaptive boosting, weighted average, blending, stacked generalization stacking, gradient boosting machines, GBM, gradient boosted regression trees, GBRT, then random forest. Then the other machine learning algorithms will be many algorithms were not covered. I did not cover algorithms from specialty tasks in this process of machine learning, such as feature selection algorithms, then algorithm accuracy evaluation, then performance measures, then optimization algorithms, etc. I also did not cover algorithms from specialty subfields of machine learning such as computational intelligence, evolutionary algorithms, computer vision, natural language processing, etc. So these are the ways how algorithms are grouped. I hope you will be having a good understanding of the machine learning algorithms and their classification. So thank you for watching this video. Thank you for your time.